Episode 2 Experimental Evidence of Inertia Reduction with Magnets Moving in the Direction of their North to South Pole. Welcome to the UFO UAP Experimental Physics channel. My name is Robert Francis, Jr. My inspiration for conducting magnet freefall experiments. Lockheed Martin senior scientist Boyd Bushman. Boyd Bushman, in an interview in the documentary From Here to Andromeda, stated that he conducted magnet freefall experiments from the fifth story of a Lockheed building that showed two repulsively coupled magnets fell slower than a control object and always hit the ground last. It was not made clear from this interview what was the cause, an effective increase in gravitational mass or a decrease in inertial mass. No one on the internet who has conducted magnet freefall experiments had determined which is taking place. I wanted to find out. The other inspiration is the Alien Reproduction Vehicle, also known as the Fluxliner. The Alien Reproduction Vehicle, as discussed in Episode 1, had an electromagnetic coil around the circumference of the craft. UFOs are assumed to have some sort of inertia reduction technology to enable their high acceleration rates while not crushing their occupants with excessive g-forces. If a magnetic field can alter inertia or gravity, it would be useful for a spacecraft like the ARV to have, and would partially explain the existence of the coil on the ARV. Peer-reviewed published magnet freefall experiments. Would it surprise you to know that there is not one peer-reviewed published article in any physics journal covering magnet freefall experiments and their results? Don't you find this strange? Freefall experiments go back to Galileo in the 16th century, and yet no one has conducted such experiments with magnets and had the results published in a peer-reviewed physics journal? There are, however, scientists who have conducted such experiments with their results available on the internet in various personal websites and YouTube videos. The experimental methodology in my experiment. The drop device consists of a wooden frame made of 2x4s with a milled out section at the top where a solenoid coil is attached via a screw. The solenoid coil magnetically couples to a steel washer on the back of the freefall object. When the coil is turned off, the object drops. The drop device has a removable MDF board with two breadboards stuck to it that has the electronics used. The Arduino Nano 33 BLE Rev 2 in the drop device controls the solenoid. It's connected to the IR sensors at the bottom. It has a buzzer for audio notifications of successful IR beam break. It's connected to a micro SD card to store IMU data, and it's inertial measurement unit data, like accelerometer and gyroscope data. And it is connected via pin to an Arduino Nano ESP32, which communicates with a smartphone for video recording. Using Bluetooth, the drop device Arduino communicates with the freefall object Arduino. Pressing the red button turns on the solenoid coil. Pushing the green button starts a video recording, starts a stopwatch timer, tells the IMUs and the freefall object to start recording, and it turns off the solenoid coil. When the IR beam is broken, the timer stops, the buzzer activates, the IMU data is transferred from the freefall Arduino to the drop device Arduino, and the IMU data is written as a CSV spreadsheet to the micro SD card. Freefall objects tested. To be thorough, I decided to conduct my freefall experiments with all possible combinations of coupled magnets. The magnets used are N42 with 2-inch outer diameter, 1/4 inch inner diameter hole, and 1 inch thick. They have 205 pounds of pulling force each. The objects tested were a control with steel fender washers with the same dimensions as the magnets that are used. There's north-south to north-south coupled, two magnets attractively coupled, falling in the direction of their north to south pole. There's north-south coupled to south-north, two magnets repulsively coupled with their south poles bolted together. There's south-north coupled to north-south, two magnets repulsively coupled with their north poles bolted together. And south-north to south-north, two magnets attractively coupled falling in the direction of their south to north pole. The magnets are encased in a 3D printed plastic shell, like the green one you can see, with some milled foam pieces to encase the electronics. A steel fender washer is superglued to the back of the shell. Magnet 10 freefall experiment. All right, this is a line chart of the north-south to north-south magnet object. I had two IMUs in the object, both recording. The maximum acceleration seen on the ICM 20649 was 11.67 meters per second squared. The average acceleration rate at the when the IR beam was broken is 10.8056 meters per second squared, with a standard deviation of 0.386. The IMU ISM 330 DHCX max acceleration was 11.93 meters per second squared, and the average acceleration was 10.9316 meters per second squared, with a standard deviation of 0.451. The p-value calculated was less than 2e to the negative 16th. The drop height was approximately 1.95 meters, and a sensor fusion algorithm was used, a Mahoney filter, to combine accelerometer and gyroscope data for the two IMUs. And the drop method was used a computer, the solenoid coil. For the control object, you can see that the error bars are much tighter, and the object is the control object's average acceleration was 9.8432 meters per second squared for the ICM 20649, and for the other IMU it was 9.8116 meters per second squared. For the north-south coupled to south-north, repulsively coupled, also about 9.8676 meters per second squared and 9.8624 meters per second squared. So again, pretty much just like gravity. The same for the south-north coupled to north-south, virtually the rate of gravity, the acceleration rate of gravity. And for the south-north, it also it was a little bit higher than 9.8. The first IMU read the average 9.9592 meters per second squared, and the second one averaged 9.9928 meters per second squared, almost virtually gravity. Problems encountered in the experiment. Washer not releasing from the solenoid coil after the same amount of time on every drop. This is likely due to the freefall object magnets partially magnetizing the washer, and it was more of a problem with the north-south one and the south-north one due to their stronger magnetic field, because the two of them coupled together attractively rather than repulsively. Tilting and tumbling due to one side of the washer and solenoid coil magnetically sticking after object release was also a problem. And the IR beam breaking not occurring at the tip of the freefall object. There are three beams, three sensors, but depending on how the object falls, the tip of the object can pass the IR beams before a beam break is detected. Now here's a little history of the magnet freefall experiments. Names and dates of magnet freefall experiments. Boyd Bushman in December of 1995. Tom Mahood in November and December of 1999. William Alec in March 2009. Magnet Tricks YouTube channel, June 2015. Rob Baker, July 2017. Elio Porcelli et al. In May of 2021. the Action Lab in November of 2021, and me from 2024 to present date. I have collected the available data from the above experiments to provide an accurate comparison between their experiments and my own. Magnet grades used. Tom Mahood used N27 grade magnets. Magnetrix and Elio Porcelli used N35. I used N42, and the others are unknown. The magnet dimensions are as follows. Tom Mahood, his first experiment used magnet that was 19 millimeters in diameter and 2.57 millimeters in thickness. His second experiment at that time used a square magnet that was 1 inch by 1 inch and 1/8 of an inch thick. Then in December, he used a magnet that was 1 inch in diameter and 4.75 millimeters in thickness. The Magnetrix channel, they used a magnet that was 60 millimeters in diameter and 15 millimeters in thickness. Rob Baker, he used a rectangular magnet that was 2 inches by 1 inch and half an inch thick. Elio Porcelli et al., he used a magnet that was 60 millimeters in diameter and 20 millimeters thick. And I used a magnet that was 2 inches in diameter and 1 inch thick. And then magnet masses. Boyd Bushman in the interview has claimed he used a magnet that was 59 grams. Tom Mahood, he used a magnet that was 5.36 grams in the first one, the circular magnet. Then in the square magnet, his magnet was 18 grams. And then in December, he used a magnet that was 36.05 grams. The Magnetrix channel used a magnet that was 238 grams. Elio Porcelli et al., they used the magnet that was 460 grams in mass, and the magnet I used was 380 grams. And then the estimated pulling force of the magnets. Mr. Mahood's, he used an N27 magnet, but I couldn't find the details for N27, so I just assumed it was I'm giving you the numbers for an N42 of the same size. The estimated pulling force on his circular magnet in November was 7 pounds of pulling force. The square magnet was 14.6 pounds of pulling force. And then the magnet he used in December was 27.8 pounds of pulling force. The Magnetrix channel used a magnet that had 220.46 pounds of pulling force. Rob Baker's magnet was 71 pounds of pulling force. Elio Porcelli's magnet was estimated, his was N35. If it was an N42, it would have 166.5 pounds of pulling force. And mine was 205 pounds of pulling force. Now, magnet drop heights. Boyd Bushman's drop height was 18 meters. Tom Mahood's 3 different experiments were all 2.4 meters. William Alex was 8.9 meters. Magnetrix channel was 7 meters. Elio Porcelli et al. Was 1.73 meters. And mine ranged from 2.13 meters to 1.95 meters. So experimenters who tested dropping magnets in the direction of their north to south pole. Tom Mahood recorded results of acceleration greater than control, but dismissed them as experimental error. Then in December, he recorded results of acceleration lower than control. From September to present, I've recorded results of acceleration greater than control. Others did not test it falling in the north to south pole, or it is unknown. How do my and Mr. Mahood's experiments differ? Well, Mr. Mahood used magnets 19 millimeter outer diameter, 2.57 millimeter thickness with a mass of 5.36 grams. And he used a magnet with 25.4 millimeters outer diameter and 4.75 millimeters thickness for a mass of about 36 grams, with an estimated pulling force of 7 pounds and 27.8 pounds, respectively. He also used an optical sensor that was unable to measure the g-forces experienced by the magnet objects during freefall, just the time in between the start and stop of freefall. I used two magnets, 50.8 millimeter outer diameter by 25.4 millimeter thickness, with a mass of 380 grams, with an estimated pulling force of 205 pounds. I used an accelerometer that was able to measure the progressive acceleration of the magnet object during free fall, and able to see from the data that the magnet object continued to increase in acceleration until collision with the ground, or in this case, until it broke the IR beam. 4 potential hypotheses. I have come up with 4 potential hypotheses to explain the anomalous experimental data recorded with the north-south magnet object moving in the direction of its north to south pole. The object's magnetic field increases the object's gravitational mass, causing it to fall faster. The magnet's field decreases the object's inertial mass, causing it to fall faster. The object's magnetic field both increases the object's gravitational mass and decreases the object's inertial mass, causing it to fall faster. The magnetic field, while in motion, causes a contraction of spacetime at the south pole and expansion of spacetime at the magnet's north pole. Here are the results from my gravitational mass experiment. If the gravitational mass of the north-south object is increasing, then it should have a higher mass when weighed on an analytical balance. It did not. As you can see, the aluminum bolts used, washers, hex nuts, and the reported mass of the magnets, and then the magnet object total mass, and they're virtually all 771 grams. 2 potential hypotheses remain. Since the masses of the 4 magnet objects are virtually identical, then alteration of the gravitational mass of the north-south object is not taking place. That leaves me with 2 hypotheses. The north-south magnet's field decreases the object's inertial mass, causing it to fall faster, or the north-south magnet's field, while in motion, causes a contraction of spacetime at the south pole and expansion of spacetime at its north pole. Did Boyd Bushman lie? From the results of my magnet freefall experiments, I saw no evidence that 2 repulsively coupled magnets, either north-south to south-north or south-north to north-south, accelerated at a rate lower than gravity when in freefall, as Boyd Bushman claimed. What if Boyd Bushman encountered inertia reduction technology during his time at Lockheed Martin? Such technology would be classified, and Bushman could not discuss it. Perhaps Bushman actually conducted his magnet drop experiments not with 2 repulsively coupled magnets and a control, but with 2 attractively coupled magnets falling in the direction of the north to south pole and a control. The experiment only used visual confirmation by witnesses at the ground level to state which object hit the ground first and which hit last. Perhaps Bushman hoped conducting and talking about this experiment would encourage others to conduct a more thorough experiment, including with non-repulsively coupled magnets, and get the science and technology of inertia reduction out to the public world. Inertial mass reduction in the alien reproduction vehicle. The electromagnetic coil around the circumference of the craft, as described in the leak of the alien reproduction vehicle by Brad Sorensen, Mark McCandlish, and Leonardo Sanderson and Gordon Ovell, is very much like a permanent magnet in that this type of coil has a north and south pole as well. So in keeping with my experimental data, it would appear that the ARV moving up vertically would energize the electromagnetic coil, having the north pole of the magnetic field on the bottom and the south pole of the magnetic field on top, in order to reduce inertia on the craft and crew as it accelerates. Inertia reduction by engineering the vacuum. The Casimir effect was predicted in 1948 and experimentally verified in 1997. When two microscopic uncharged conductive plates are placed close enough together, they get forced together by the energy of the vacuum. Essentially, the energy of the vacuum trails off rapidly with distance, but if the plates are placed close enough, there ends up being more force on the outside of the plates than is inside the plates, which is why the plates get pushed together when placed extremely close together. What is creating the force demonstrated by the Casimir effect? In quantum field theory, it is believed that virtual particle-antiparticle pairs are constantly popping into existence and annihilating. That minimum most amount of energy in the vacuum is called by some zero-point energy. When the virtual particle pairs of positronium, composed of a positron and electron, pop into existence, they usually rapidly annihilate and create short-lived, extremely high-energy photons known as gamma rays. Gamma rays, due to their high energy, impart more momentum on objects they collide with than any other type of photon. It is my hypothesis that these virtual particle pairs and short-lived dark gamma rays, virtual gamma rays, that are created upon their annihilation are behind the Casimir effect, and that virtual particle pairs can be manipulated prior to their annihilation to decouple a craft from the energy and momentum of collisions with virtual dark gamma rays. I believe these virtual gamma rays are responsible for inertia. I believe the Casimir effect can also be engineered to generate over unity electricity, but I cannot say if such a device is what powers the ARV. Using a pulsed magnetic field or a moving static magnetic field, the coil's field imparts a torque on the virtual particles of positronium, causing their axis of spin to align with the magnetic field lines. When the virtual positronium annihilates, the two dark gamma rays are created, one traveling up, the other down, parallel to the field lines of the magnetic coil. Instead of impacting the ARV and imparting their momentum on the craft, they fly off harmlessly before disappearing back into the vacuum. I believe this is what is also happening with the permanent magnet objects that I dropped, specifically the north-south one. Conclusion. Join me again in about a month when I have completed the next step in improving inertia reduction technology. I am designing and building a rotational inertia device which attaches two north-south magnet objects to the periphery of an aluminum disc and rotates that disc at a fixed RPMs in the direction of the magnet object's north to south pole. Then I flip the magnets so the disc is rotating in the direction of the magnet object's south to north pole at the same RPMs. By connecting a current sensor in between the power supply and the stepper motor driver board that controls the motor, if inertia reduction is taking place, then less current will be used when the magnet objects are moving in the direction of their north to south pole versus south to north pole. I now have a complete experiment replication guide on my website to replicate the Mark 10 experiment discussed in this video in its entirety. Everything from the free fall object and all its components to the drop device and all its components, the electronics, the software code used, all of it. The only way we're going to move forward is if we multiple people come forward with evidence of inertia reduction technology. It can't just be me. We need lots of people replicating these experiments and adding to the body of evidence. The results of the experiment and the replication guide can be found at robertfrancisjr.com/mark-10. Thanks for watching.